Hello friends, welcome to this session. Today we'll see the power of parallel programming using ForkJoinPool and recursive action. Let's say I have around thousands of job that I'll have to do. Okay, if I use single thread and do each job, then definitely it will take a lot of time because the single thread will execute a job. Once that is finished, then it will take another job, and it will like to execute all the thousands of jobs. Definitely it will take a lot of time. But if I submit this same 1,000 job to a ForkJoinPool, then if like ForkJoinPool basically have a pool of threads that have the capability to execute each job in parallel, okay, based upon the threshold setting you have. So I have created a small program here. If you go here, you can see I have a job. So this is a job class, and inside job class I have a function called tags, and this basically doing nothing. It's just like when this function getting called, is just to wait for some time. Okay, let's say this is a job, and this job is like executed in a sequence fashion, like in a sequential manner. And when the job start executing, I just kind of like take the current time. Then when all the jobs getting completed, then I'll see like how much time basically it takes. So it's just a simple for loop, and then this for loop is for 1,000 time. And let me run this program and see how much time basically it is taking to complete all the thousands of jobs. So you can see like it's executing job. So here if you see, it's also like I'm also printing the number of active threads, like how many threads are currently active to execute the jobs. So it almost take like 15,000 milliseconds to complete all the 1,000 jobs. Okay, let me take this for my record. Now let me execute the same 1,000 tags using a ForkJoinPool. So before that, what I'll have to do, I'll have to create the recursive action. So recursive action is basically it is basically talks about um, the number of tags that I can create for the job. Okay, so if you see like the recursive action is basically the abstract class that is present in Java util concurrent package, and I need to extend that recursive action class, and I'll have to go to the compute function. So the compute function is basically it basically checks for the threshold. Let's say I have set the threshold as a 10. That means uh, if if uh, if the number of jobs is more than like 10, then it will kind of like fork the jobs, like it will create the subtags of jobs. So here you can see like it will create the subtags of jobs. Let's say I have 1,000 jobs, then it is more than 10, correct? So first 10 job will execute by one thread, but the next 990 jobs will execute by pool of threads. Okay, so then these are the, I can say these are the soft tags created. So these are the soft tags, and I can like this soft tags getting forked. Okay, so this is the recursive action function I have. It is simple recursive action, which is basically divide a bigger tags into small subtags depending upon the threshold value. Okay, then I have the main function. If the main function, you can see like again I just try to start the timer, and then I have the job created. So this job is submitted to ForkJoin tags. So the ForkJoinPool basically needs a ForkJoin tags, and that ForkJoin tags is basically created using the job that we want to execute. Then we will have to create ForkJoinPool, and this ForkJoinPool is with the argument 10. That means I can have maximum 10 thread should be available in my uh, in my ForkJoinPool. Then I submitted the task. Then I just have to wait whether all the tasks is getting completed, and once that is done, I just try to then what is the total time it takes. As you already have seen, like in my previous execution, when I have a single thread executing all the 1,000 jobs, it is taking around like 15,000 milliseconds. But if I'll do the same thing with ForkJoinPool, you can see like it is very quick and it is almost complete in 1100 milliseconds, which is almost like I can say 10 times faster than uh, the um, the previous execution where I have executed the jobs in a sequence manner. So definitely you can see this is the bigger difference in the performance when you have executing similar jobs, similar kind of jobs, then it will be good like you can execute it in parallel. Okay. And here you can see like the number of active threads is 11 because I have created 10 threads in my function pool and one thread is the main thread. So all total there is 15 threads. Okay. Now let's say, let me increase the thread size to 15. Okay. So in that case, if I have more threads available to execute same number of jobs, then definitely I'll see some improvement in the performance. Okay. So let me run the same program once again. Here you can see like I have 16 threads, and now you can see like it is almost like it takes around like 800 milliseconds to complete the same number of jobs as I have more number of active threads are available. So here it's 15 and one is for main thread. So total number of threads is 16, and now the 16 threads is executing the 1,000 jobs. Okay. So in that case, like you can see like how the like parallel programming is powerful than the sequential programming, because this, if we have similar kind of job to be executed, it's always good to go for the parallel programming. And when you go for the parallel programming, ForkJoinPool is one of the best choice you can have, correct? And it basically on demand it will kind of like create the it will basically divide these bigger tasks into small tasks and it will execute in parallel. Okay, so this is the benefit that we can see using parallel programming. Thanks for watching this. Please like or subscribe my video, and in my upcoming video as I'll go in detail about the multi-threading programming in Java. Thanks for watching.